Welcome everyone. Today we will be talking about NLP, Natural Language Processing. First part of the presentation, I'll cover what is language itself and then what is natural language. And towards later part of the session, I will cover processing of the natural language, that is NLP. This session is conceptual, theoretical in nature, no code samples and no hands-on coding as such. So only theoretical considerations related to natural language processing. So we'll see what is language itself. So we use language in everyday life. Some of us, especially Indians, know more than one language. And that's not the case with many other countries. But then when we say language, what it is that we'll try to explore now. Use language in multiple modes. We speak the language, we read the language, and of course we write the language, all using certain set of ideas. Language is an idea in the practical use. If you go a little higher, we also think in the language. We also dream. We express things in the language. We make decisions, we make plans, and we try to put whatever we think in the form of language so that it is communicatable. So all that what we do, we speak, we write, we express all that in language. To put it little bluntly, in words, right? That's what language means. I'm giving this background because then we'll see what that language is, what is natural language, how hard, how challenging it is, and then we'll see how to process that language for certain applications. All right. So, as we said, language, at least whatever we speak, write, read, is made up of words. Now, given a word, how do you understand that word? That's what we are going to explore now. Is word equal to its meaning? Meaning, let's say there's a word crab. Okay. When you read the word crab, C-R-A-B, when you hear the word crab, what do you imagine? Is it just a bunch of letters C-R-A-B or something else that we'll try to understand? We, of course, the first part is actually a pronunciation, the way to write pronunciation. Okay. Crab. The middle one is, of course, the English, the written part of it. And the third one is visual aspect of it. So the word crab, the symbolic representation, how does it convey a particular meaning? A crab for one person, the word may be little different from whatever another person understands. This ambiguity is not trivial. Language brings that ambiguity, and while processing the language, that ambiguity needs to be considered. That's why I'm doing this very basic thing to start with. So, word crab actually has sound, has letters, and has image associated with. All three combined, probably we understand. We understand the meaning of the word crab. If by any chance, first two are there, and the third one is an image of an elephant. So there is a dissonance. There is no congruality. Then there is ambiguity. So at least there has to be coherence between these three so as to help in the understanding of the word crab. What difference here? Similar thing, but a different language, right? Probably it's a Russian. So another person who is familiar with the first two can understand that. But the third one is same, sort of same for everybody. So there are different ways of interpreting the same thing, same concept. So why do we do this, right? Why do we try to understand word, sound, sight, everything? Why we analyze the language? Because it's a mode of communication. It's actually a vehicle, it's a medium of storing knowledge, retrieving knowledge, and retaining the knowledge in brain, right? It's a repository of human knowledge. And when we process that language, we can have multiple applications, and these applications are all around us. So this SMS that you write, the predictive text that you get, handwritten recognition, many things that I've mentioned here, web search, completely language based. Virtual assistants, Alexa, Siri, although we speak that, finally it gets converted to words and then gets processed, right? Knowledge extraction, knowledge storage, everything is language related. So language is a cornerstone, in my opinion, of civilization. Of course, there was civilization before written language came into picture, but still, at least the modern civilization is full of language. These are some of the questions you can ponder over. So there are language-based systems now, which we have been using, which we are using all the time. But any limitations that you can see, just think over them. We'll try to understand what these language technologies are. As you can see, initial part is very, very high level, sort of very theoretical, but it will build foundation of NLP, natural language processing. So we'll see what is NLP. Let's take one example, at least some who are even now, there are systems like called IVR, interactive voice responses. So when you dial some bank or some customer service call center, typically you get this thing, right? Press 1 for English, press 2 for account details. If nothing works, then of course press 9 to get a human guy, right? So this is traditional IVR. As you can imagine, as you have gone through yourself, this is very, very frustrating. I just wanted to know my account balance and I have to press this, press that, till the guy comes and probably fifth level, sixth level, I'll get what I want. Instead, now there are chatbots. Those chatbots, you can see them on bank websites also, right? And then at many places there are conversational AIs, meaning chatbot for everyday use. So there you don't have to do press 1, press 2, press 3. You just directly ask once you log in, the credentials are available at the chatbot's end. What is my account balance? That's it. And you can put them in different formats. It's just not what is my account balance, how much do I have? If I say so, meaning wise it is same, right? Still, it should be able to theoretically understand and it should give you account balance. One important thing is instead of course, traditional IVR is also automated processing. Previously, there used to be call center. Even now, there are manual call centers. Humans answer things. For such cases, modern solutions chatbots are far more advantageous in the sense their availability. 24 by 7, you can have thousands of chatbots, so no volume, no scale issues, plus no tiring, no giving wrong answer. All these questions are gone. All these problems are gone. Because of such situations where scalability is issue, where errorness, the human error and other things are the issues, these language systems have been employed worldwide. And of course, these are some of the players which we all know, and these are some of the examples related to chatbot-like things. But there are multiple usages which we will see little later. So what is natural language processing? Now we are coming close to our topic. So first we saw high level, what is language, words and their meaning. Now we saw an example which forced sort of suggested us to have automatic language processing, which is scalable, which is less error prone and those qualities. And that is done by processing natural language. So we'll see what is NLP, natural language processing. What is natural language? Languages spoken by humans. English, French, English, Marathi, Hindi, all those things. But there's another set of languages which most of us have used, which are called as formal languages. These are basically programming languages. And we'll see the difference. Python, Java, C++, R, whatever, all this. So NLP is related to processing natural language, not the formal language. Formal languages are processed by compilers. Natural language are a little difficult, complex, and we'll see why. So NLP is nothing but techniques, processes, processing of natural language for computer applications. It of course involves computer science because there are algorithms. It involves linguistics, meaning science of language, because we have to understand the structure of the language. Of course, AI, all those machine learning, deep learning related techniques, and then statistics. In a sense, the part of AI now, I would say, some are frequency-based statistical techniques as well. Okay, so here is the distinction. Formal languages, for now, let's say programming languages. And natural languages is what we use for normal everyday communication. So these are the differences. I won't go one by one, but I'll let you just go through them yourself. I'll give you high level idea. Formal languages, programming languages have very strict rules. The for loop has to be written strictly this way. Even if you miss semicolon, comma, whatever, the compiler cribs. It doesn't go further. So it has strict unchanging rule. Versus natural language are, they have rules. Of course, there is something called as grammar. But sometimes grammar is a little flexible. And you can always see the way we speak is not strictly the way we write also, right? We have slangs, we have other words. So it's a little flexible, it evolves. Nowadays, there is a Gen Z language, there is a social media language also, which is strictly not English per se, within the English domain. Another thing, this is application specific, formal language, very literal, very strict, no ambiguity. If you say for 1 to 10, it means for 1 to 10. Whereas natural language is very, very ambiguous, especially for there are multiple flavors. You can speak straight, you can speak sarcastic, especially those who are coming locally from Pune. They are very well aware. And there are different shades of language. Why I am saying this? All these shades, all these characteristics of language, being straight, being sarcastic, have to be processed by NLP so as to make meaning out of it. Unless we address all these complexities of natural languages, we are not going to build good NLP application. That's why we have to consider them. All that flexible nature, all these emojis nowadays, emojis is another language now. We have to process emojis in case of sentiment analysis, right? That's why we are considering various aspects of natural language. And it is highly context dependent. This is another thing. For loop in case of Python, if you write here, 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 before you write something else, wherever you write for loop means for loop, right? That's not the case in case of context natural language. So language, what are the components? Typically words, rules. That's grammar. Sometimes grammar can be violated. These are exceptions. And then of course context, the surrounding, right? So we have dictionary, set of words, we have grammars, we have semantics, the meaning of words, and the pragmatics, context and the social use, where we are speaking about it. All right. Let's look at some of the NLP challenges. Why natural language is very, very hard. There are challenges. Now, one challenge, and I've got a couple of examples now, couple of slides on challenges. One is paraphrasing. Okay. Um, Different words express the same meaning. Okay, we always have for a single meaning, say we have different words expressing. Of course, there are some shades of differences, but generally, say they have same meaning. Say fall and autumn. Fall in case of it's always the season towards winter in our case, right? Or towards between monsoon and winters. So book delivery related question. All these things, as you can see as an example, they're different words, but they're sort of asking the same thing, isn't it? Why I'm giving this example? Because we have to process all these four examples and give the same answer, right? That's why this different words meaning the same things has to be captured in our processing. So, as I said, what is my account balance and how much money do I have? Words are very different, but the meaning is account balance, isn't it? So chatbots or any conversational AI, any natural language processing algorithms have to cater to this paraphrasing. Another thing, ambiguity. Okay, we have taken, so one word can have different meanings. Okay, we saw um, same meaning, different words. Now we'll say one word, different meanings, opposite. So fall is what we saw. Fall in case of seasons is a season, autumn and fall. But fall as an action is a fall, right? Going down. So third season of the year and moving down towards ground. There's another meaning related to drapery or clothes. The fall has a different meaning. In case of at least Indian ladies use that word fall, as far as at least the sound that goes. So the door is open, expressing a fact, a request to close the door, right? Same words, different meaning, different action expected. Okay. So last one is a little tricky. If you can see syntactic ambiguity. Now I've given an example here. I saw the man with a telescope. So there are two meanings to this sentence. Now put it in chat window. Answer the question: Who had the telescope? I saw the man with a telescope. The man had telescope. I saw a man with the telescope. Either I can have telescope or the man can have telescope. Isn't it? Both things. So there is an ambiguity. How do you answer this question in such cases if you're building a chatbot or an answering system? That's why NLP is very, very hard. Syntactic complexity. The astronomer loves the star. Now, star has different meanings. Star meaning celebrity star or the star in the sky. But the context here is crucial. Is if somebody is talking, if the whole article is about astronomy, then of course we are sort of clear. If some article is talking about movies and entertainment, then we are sort of clear. So context is necessary in many cases. All right. So that's why NLP is very hard because of ambiguity. There are too many words. Context has to be provided. There's some implicit knowledge, cultural knowledge. If you say something in Pune, if you say same thing in say Delhi, the meaning could be different. I'm just giving some example. Order is important, at least in English. Dog bites man versus man bites dog. If you make the language processing orderless, order independent, then the whole meaning goes off. Of course, that's not the case with languages like Sanskrit mostly. We'll see that example little later, probably in the next session. All right. So language is rich, but there are a lot of challenges. And we have to process this language so as to make effective natural language processing applications. So that's why, in my opinion at least, NLP is real AI. What is AI? It is human-like intelligence displayed by computer programs, software, or algorithms, right? So for that, one has to understand, meaning as humans understand the language, AI has to understand the human language, whatever the input is in human language, natural language. If AI is able to understand language similar to what humans do, then in my opinion, AI has arrived. Let's take one example. So we all have done in our school what is called as comprehension. Given a paragraph in our exams, some questions are asked based on the content of the paragraph. We have to answer those questions, isn't it? Assume same thing has to be done by a natural language processing algorithm that you are writing. You are writing an application, given any paragraph. Once the paragraph is given, and then questions are asked, you should be able to, meaning the algorithm should be able to answer from that paragraph. Such a difficult problem. Just imagine how difficult it is. One has to understand the paragraph well. Well, some of us humans also can't answer because our own comprehension, or else we all would have got 10 out of 10, right? Some of us don't. Meaning we also don't understand the language well. How can you expect AI to understand the language well? So these are the challenges. But we have to solve these challenges so as to answer these questions because this is just an abstraction. Some academic example I've taken, but such situations arise on every step in natural language processing algorithms. Given a tweet, tell me whether it is a positive tweet or negative tweet. Given a product review, one paragraph, somebody has written, my fridge is this, my fridge is that, whatever. I bought it from here, it was expensive, it did not work, but it worked on this occasion. All these things one has to understand and say that this product review is positive or negative. Why it is necessary? There is money involved. If you see, there's a business requirement like that. So that fridge company will go on collecting all these reviews and aggregate the product reviews and say, overall, what is the sentiment about my product? Is it positive or negative? Is it too negative, too positive? So there is a business case associated with processing the language. So understanding of the language is essential. However challenging the language is, however hard the processing is. All right. Now, little theoretical concept. There's something called as Turing test, named after the same person, Alan Turing, on whose name there's a Turing Award. This test is very old test, as you can see, a 1950s kind of test. And AI, the word AI was sort of born in the same decade, 1955-56. So just imagine this situation. Uh, you are sitting on one side of a board. You cannot see beyond the board, right? Behind the board. And you are chatting via computer with something behind that board. You cannot see that thing who is chatting with you. You can see you are on this side and there's something on the other side and this is the board and you can see behind it, right? Now this test, what does this test say? When you're chatting to that thing, if you're not able to decipher, if you're not able to understand to the thing with which you are chatting, is it human or a computer? If you don't understand, meaning the answers coming from that thing are so good that it feels like it's a human only, but actually there is a computer behind. So if such state is arrived by the computer, meaning algorithm, then AI has arrived. This is the Turing test. I think hope everybody's getting it. So the party to which I am communicating, chatting with, I'm not able to understand whether I'm chatting to a real human or an AI system or any system, software system. It is that good. That's when we say that AI has arrived. Till that time, sometimes, as you can easily see, sometimes the answers are very cryptic, some answers in a speech system, they are very robotic. Then we surely know that this is an AI system. It has not reached human levels. So, same test, when human levels are reached by artificial intelligence system, then we say Turing test is passed. Right. I'll quickly go over history of NLP. I won't delve too much on history of NLP, and later I'll actually show what are the processing approaches, what processes we do on natural languages, and what are the applications. See, these two things are crucial, important, but we'll see language, as we can say, coming right from the start of this civilization, I would say. But for us, AI enthusiasts, 1950s when Turing test is proposed, then there was a chatbot called Eliza. I think it is still there. Somebody has that even built even today. So where you ask some questions and that system answers you with the help of same questions. Okay, this was built that time for lonely people, those who have some psychology related problems. And this system was not, of course, the current AI like system. It was rule based AI. What it used to do, I have seen some sessions of Eliza. So you ask some questions, and then it takes the same questions and try to formulate answer based on the same question. Right? This is how it was programmed. It was rule based and deductive language. So if you can see, um, what does your whatever it depress you, then you can see the patterns. Say my friend depresses me. Why does your friend depresses you? Can you see the question mark and X? Same thing that was there in the question was used in the answer also. Life hurts. Why do you say it hurts? Right? Can you see it's just the replacement? This is how Eliza was programmed. And say, as you can see, you can go on chatting with this Eliza, right? And as you ask the question, it will start answering the questions. But it was a fun experiment. Then, of course, came linguistic approaches. Noam Chomsky is still regarded as one of the pioneers of linguistics. Um, First on that. Then, of course, came so initial processing, even things like machine translation, many translators, language processing, all things were rule based. You wrote the logic. Then came use of machine learning, supervised sentiment analysis using supervised data, meaning having input as well as labels. And then so those machine learning approaches came. Then came deep learning based approaches. Word embeddings. This is a typical deep learning based approach. RNNs, recurrent neural networks, LSTMs, long short term memories. Those networks, these are neural net. Then came, of course, the very famous transformer architecture, which brought attention mechanism. Um, and then these are some of the recent advances. All right. So now the question is, why NLP now? Of course, NLP was there, and then why NLP now? Because for these approaches, especially deep learning based approaches, neural network based approaches, we need lots of data, and lots of data is now available because of internet. Everybody, almost everybody is on the social media. They're chatting left and right. So posts, blogs, and then many things. So that data is actually what is used for language modeling. You see what language model. So web text, social media, books, articles, people are just churning out the language resources. So data is available. For processing that huge amount of text data, by the way, text and speech data will, in some sense, can be combined as far as language processing goes. Okay. Then compute is available now. You're not limited to your laptop now because of cloud, availability of GPUs, CPUs. Processing huge amount of data is now possible. Um, and then, of course, algorithms. There's a huge development, not just now old rule-based systems, now machine learning-based, deep learning, transformer, now these GPTs, encoders, decoders, all these networks are now available. Some of these algorithms are free. So you can use these algorithms in different frameworks. Typical frameworks, at least specific to NLP, are NLTK, which is sort of academic in nature, NLTK, Natural Language Toolkit. And there's an open source but very industry grade library for NLP is SPACY, SPACY, C capital Y. All right. So, as deep learning needs a lot of data, if you want to process language using deep learning, meaning text using deep learning, we can leverage the big data. This slide is very important. I'll go very slow on this slide. This is actually the history of NLP, if you can see. The initial systems were rule-based. By the way, even though I say rule-based is old, machine learning is little later, deep learning is later, and LLMs are what is there in the fashion today. But as I've worked in this domain for many years, all four approaches are relevant today. So the systems that I'm personally part of, we have used rule-based approaches also, ML, DL, LLMs, everything in the same application because there are advantages and disadvantages of each. So rule-based, very simple example is regex, regular expression, certain patterns. Say the way email is written, the way phone numbers are written, they're sort of standards, right? There are variations, but more or less there are set patterns. For such cases, why do we use machine learning? Because for machine to train machine learning model, we need supervised data. Deep learning, same thing. LLM, huge data. Why use a cannon to kill an ant, right? That's the idea. So when things are very clear, deterministic, use rule-based methods. Machine learning is where feature engineering is possible. Then there are approaches like CRF, SVMs. For say typically for different applications, finding parts of speech, finding named entity recognition. We'll see those examples. For such examples, machine learning is typically used. For things like machine translation, doing summary, deep learning is used. There are specific model for summarizations, specific model for English to French, another model for English to Hindi, those things. And then, of course, LLMs, large language models are the latest ones. They are huge models because they are trained on large amount of language data. Plus, they are large because their network itself is large. If you all can recall, the model behind ChatGPT, GPT 3.5 Instruct, it has 175 billion parameters meaning weights in the neural network. It is huge. So this is the progression, but as I said, for enterprise grade application, all four approaches are still relevant. Some examples, rule-based approaches. Um, I'll not go through this, but you can just glance over them. So given a sentence like this, can we parse this sentence based on, say, rules, right? So meaning, show me is together flights from Boston to San Francisco. We'll see one a more advanced version of this sentence processing called NERs in more details. This is the one. So from given sentence, actually what I want, if I'm building a chatbot to build flight booking applications. Huh? Show me flights from Boston to San Francisco on Tuesday. I need only three things, right? I need origin, Boston. I need destination, San Francisco, and I need date. Apart from that, as this is my flight booking application, I don't need anything else. Now, imagine if you're writing a rule-based application. Yeah, there could be a rule that things starting with capital are cities. Just imagine you want to find two cities, right? What logic would you put? It's very, very hard. Now, there are four things in the capital, or five things actually. S from show, Boston, San Francisco, and Tuesday. Now we have to understand how. Out of them, three are related to cities. How do I do that? First one you can ignore. Just imagine yourself how hard it is. Now, assume that the first one and last one you are able to discard by some logic. The middle three things are cities. First one is Boston, but the second city has two words like San Francisco, New Delhi. No, it's not a single word also. So such things are built using different approaches. Actually, these are called NERs, named entity recognition. Boston is an city or location, LOC. San Francisco, two words, single token. You should say token for now, okay. Again, a city or location. Choose this date type. So if you are able to build NER models, then we'll be able to extract cities very quickly and then answer the question. So this is the chatbot question, which we would be able to answer now. From Boston, San Francisco, Tuesday. What are the, it just then becomes a SQL query, a database query. But processing this input English sentence to an SQL queryable entities is very, very hard, isn't it? That's why natural language processing is hard. Same things, another example, we can, so NER, named entity recognition, can be done rule-based way as we tried to do the capital ones and other things. Here is another approach, the machine learning approach, conditional random fields. It is based on probability. After this word, there is a likelihood of city coming next. Once city is there, from that, the probability of next two words of being a city is also high. That kind of model it works on. Here's another one. I'll let you just have a look at it. So this LSTM is um, LSTM is actually a single cell, but LSTM based sequence to sequence network, encoder decoder network can be used in this case of NER, where there is an English sentence and in the training, and at the decoder side there is a IOB statement. IOB is another syntax to represent NERs. Let me not go into details of it, but probably in some other session, I'll explain this process in very detail. Basically, they are tokens that these are other words. Then the city starts. I is intermediate, O is other, and B is beginning. There's something called IOB format to represent NERs, named entity recognitions. So in case of show me flights, the output statement will be other, B is beginning, then other, BI, because BI is this city has two words, so beginning and intermediate, again other and other. This is for just city. Okay, this is the NER way, IOB way of showing the output. So this is English sentence and IOB statement. It is trained this way, LSTM, encoder decoder network. That's how for any once the model is trained for any unseen English sentence, it is able to spit out output the IOB sentence, and then we are able to find out which are the cities. This is how it works. I've personally worked on this quite a lot. And then of course this LLM approach, you just put a prompt and you get it. So this is what I wanted to show. All right. So we saw what is language, the complexities of it. We saw what is natural language, and then 4 ways of doing it. And we'll see some of the component process concepts, the language processing steps, approaches now. First one is given a text, before we process it, if it is a document, then we have to split it because we cannot process like 100 pages at a time, right? So there's something called as splitting. It's also called as segmentation. Segmentation meaning splitting only. Another word for this is chunking. These are sort of, they all mean the same thing. So document section splitting, given a document, split at the page, split at the sections. The smaller way of splitting is split in the sentences by full stop or question mark, split at the words, white space. All these ways of splitting are essential as a first component of natural language processing, isn't it? Once we split them, then we will be able to manage their processing later. So now we are saying core NLP tasks. First one is, of course, within text processing, splitting. Another one is called tokenization. Again, it's also called as tokenization, breaking text into tokens. So given a word, so sentence tokenization meaning splitting the sentences. Word tokenization, given a sentence, we will split at the words. But there is something also called as sub-word tokenization, meaning splitting within the word. Right? Going is a word, G-O-I-N-G. We can split into GO and ING. Why this is done? Imagine we have huge amount of data, right? So all this splitting will collect all the words used in this. This is what is called as vocabulary, and that vocabulary is processed later in by machine learning way or deep learning way. Okay. Now, the lesser the vocabulary size, better and faster it is to process. So imagine, so if I have just going word, split into two, there could be many things where go can be common, so we can just store go once. ING is seen at multiple words, but once it is split, you can just put one ING and use its ID. So we are trying to shrink the vocabulary. Don't know whether it is making sense, but these are common things that are split so that vocabulary size is less. I'm just giving you some high level processes that are done in NLP. Cutting the words, detect, and ing, isn't it? This is what is done. So sentence-wise splitting, word-wise splitting, there's similar things. Stemming and lemmatization are similar. Only there's a difference that stemming is real hard cut, just cut at certain by some rules. But lemmatization is when you cut, make sure that the both things have some meaning. They have some linguistic understanding. So it is not hard cut per se, but it is linguistic cutting. All right. Another important thing that we do in NLP is pause tagging, POS, parts of speech. Those who are from English medium probably understand, and even from other mediums. So we will try to find out what is name in it, what is noun in it, pronoun in it, verb, adverb, adjective, why it is necessary. Just imagine our original question. Show me all flights from Boston to San Francisco on Tuesday. If we are able to do pause tagging well, parts of speech tagging well, if you have a model, then this Boston and San Francisco will fall in proper nouns, right? So all other things, verbs and other things, I can just ignore. So once if I get a past tagged sentence, I can just concentrate on these things. That's why this is necessary. Past tagging, building parse trees to find out relationship. And I'll go little fast now. All right. Syntax tree examples. This is all rule-based days that we used to process dependency parse trees on in ER, as I just mentioned. From English sentence, find out entities, named entities recognition, meaning entities like person, organization, location, date, time, all this. This is a very, very important process in NLP. All right. And then, of course, another more popular or more recent ways of doing it, convert those texts to numbers, meaning vectors. Once we convert word to vectors, then all the machine learning, deep learning, meaning neural network approaches are available to do summarization, translation, sentiment analysis, and everything. We're going to have dedicated session on word embeddings later. This is how it is. If you can, by some good way, if you are able to represent words or sentences by vectors, by numbers, then all the approaches related to machine learning and deep learning are available to us to do all those processes. Word to vec is what we will see in word embedding session in more details. The fantastic properties, these vectors, word embeddings obey linear algebra, meaning vector algebra. All right. Last session now, applications of NLP. Why we are studying language? To do what? To do this is what we'll see. Can we do categorization? Given a text, all must have seen in our email applications, some of the mails automatically go to spam folder. What is it? Given an email that has come, a machine learning or deep learning model is applied to it. It says that this is a spam or not spam, meaning ham. Accordingly, it automatically moves that message to a spam folder. So spam detection, sentiment analysis, all these things are intent classification. Given a query in a chatbot, is it bank related? Is it loan related? Is it investment related? This is first analyzed by an intent classifier. Then accordingly, those databases are used for querying for that original English query. Okay. So text categorization is important NLP process. Sentiment analysis, sort of similar. Product reviews. As I gave that example, is the product review positive or negative? Social media monitoring. How is this tweet abusive or not? Again, classification. Again, categorization. Um, all those things are category analysis. Sentiment analysis. By the way, there are products which look at all the social media aspect related to say a particular stock. They find out the sentiment analysis. Oh, is everybody is gung ho about it? Everybody is positive about the stock. Probably the stock will go up. So that kind of analysis also people are doing. Information retrieval, again, very, very important. As we can see, you put something in Google search or any other search engine per se. How does it retrieve the information? How does it understand all the database that it has got? It has been indexed very, very efficiently, and it brings you the information. So information retrieval is very important language process. Information extraction, given a piece, can it make it structured? If you can say this is a Wikipedia page, if you've seen Wikipedia page of any world leaders, no, many famous personalities, you have text in the middle, but on the right hand side, there's actually a structured text box where name value pair is given. It is actually extracted from this. By the way, I was a similar database, not Wikipedia. There's something called the DBpedia. I was sort of associated with that project to extract structured information, meaning key value pairs, basically, from given unstructured text. Text is unstructured. There is no rows and column, no key value pair, just free flow of words. From that, can you get this? Meaning what? So this is Angela Merkel, I think. Yeah. So her name, when she was born, her political parties, spouse, and other things. All these things are key value pairs. If you can see the category and the answer, category answer. All these things can be extracted from the free flowing text. Why this is necessary? Because we can query it. If I have such information, so assume in a single row, a leader's name, a birth date, and then other things, all these things. I have thing for all these leaders. Can I query them? Who is 60 years old and above? Easily queryable, right? It is not queryable easily from the free flowing text. That's why converting unstructured from unstructured text to structured knowledge is very important. This is done by information extraction. Machine translation, another very important case from English to Hindi, whatever, Hindi to Marathi. All these things, you can see it in Google Translate or any other. LLMs also do these things. Initially, it was rule-based and statistical. Now, of course, neural network-based. Now, of late, it is transformer-based. Question answering, all the chatbots that we see. Another important set of applications. If you can just imagine all these applications that I'm speaking about, they have commercial applications. So if and once you become good at NLP, you become eligible to work on all these applications and then make money. Summarization. Who will read all these books? Just give me a summary in 10 lines. All these things are available. These algorithms are available. There's something called as extractive summarization. Just it picks up only important sentences, doesn't tamper with the text. Just important sentences. Another thing is abstractive. It understands and makes a real summary of it. I've personally worked on this as well. Topic modeling, finding some important keyword patterns, topics, actually important things within the text. Nowadays, of course, because of advent of large language models, we do not have one model for say summarization, one for sentiment analysis, one for this thing, one for that. No, now these foundational models, meaning they can do multiple things. One model can do multiple things. Of course, there is specialization. ChatGPT can write code also. ChatGPT can do Q&A. It can do summarize. But there are, of course, very specific specialized models also. So Codex is for coding, programming. O4 is for say reasoning. But these models are typically foundational, meaning they can do many things. All right. So I'll just let you read this. This is modern NLP now. This is what we have to deal with. We are able to build RAG applications. We can do RLHF and then many things. All right. Spell and grammar checking is another thing you might have seen. All the word processing. You can have a red line. It gives you all the options. Just imagine what is the algorithm behind it. You have misspelled a character and immediately it comes up with the proper word. There are probably say 3 million words in the dictionary. How does it bring in the correct set of probable words in split second? Amazing work people have done. Word prediction is what we have seen in Google also, Gmail also. It starts giving next words now. While typing SMS also you get this thing. So I think we are coming close to the end of this session. So this is the current state now. Multiple applications are possible with NLP. This is an important slide you can go through. Some of these things are mostly solved. Some of things we are making good progress, and then some things are still out of our hands, or meaning less progress. This is basically an opportunity list. that I'm presenting here. Right. Nowadays, it is all large language models, so we have to be good in large language model. So next session we will have word embeddings, and later we'll have large language models. Yeah. So the applications are enormous in multiple industries. Personally, I've worked with this last one, legal document processing, for many years. All right. So, of course, it is still not a solved problem. Language, in my opinion, is never going to be a solved problem. So there'll always be work in NLP. So if you become good in NLP, then your hands will be full, in my opinion. Because language is ambiguous, language is hard. That's why the challenges will be there, mostly. All right. We'll have a quick look at the summary. Definitely an exciting time to be in NLP. Many things are coming day by day. So if you are in NLP with some ready problems to work on, you'll find it exciting. I've used multiple publicly available resources for making this presentation. Many things are available on net, YouTube. There's no dearth of knowledge here. All right.